So let's go over what I've covered in today's lecture. So the first important thing was that computers understand the instructions of their specific ISAs. This is to say that, say I have a mobile processor that's like an ARM processor versus my laptop, which is like an x86, those two processors do not understand the same instructions, and you'd have to do translation if you wanted that to be able to interpret it. We also talked about the RISC design principle, which once again RISC stands for Reduced Instruction Set Computing, and the whole idea is that we want to keep everything simple, and smaller is faster. We also went over the different registers that RISC-V has, so S0 through S11 are the save registers, and then we also have the T registers, which are the temporary registers of T0 through T6, and X0. There are a few more registers than this, and we'll cover that in a little bit, though it's more to do with how functions work with assembly, or how you deal with, or how you make a function in assembly. Finally, we went over some different types of instructions that were useful. For example, we went over some basic arithmetic operations like add, subtract, and we even did some arithmetic operations that it required an immediate, such as ADDIE. We then talked about how we needed to transfer data from the CPU and the data path to your memory unit, and we accomplished this with load word. We also need to store word. We also need to take data from memory and load it into our CPU, and we can use store word to do this. In RISC-V, our memory is byte addressed as opposed to other systems which might use word or half-word addressing as well. Though you don't necessarily need to do aligned operations when you're doing stores, so you don't necessarily have to store a word and make it aligned, though it's highly recommended as you'll have much better performance. The final thing we really covered are control flow instructions, which are branches such that I want to go to a different part of my code if this is true, otherwise I'm going to just go and continue on to the next instruction if it's false. We also have the unconditional jumps, which are jump like JAL and JALer, which will jump to a specific part of the code regardless of if a condition is met. There's no condition for those type of jumps.